Okay, we are going to just take this to the next step. Working on a project right now where we've got some imagery downloaded from Glovis, which is a USGS interface. It's LandSat8 imagery. We are taking all of the LandSat8 data, and we're using the composite bands geoprocessing tool in ArcGIS Pro to create multi-band TIFFs that could be utilized to view different wavelength ranges and different band combinations. And we've downloaded 4 different scenes from different dates. We've got one from before a forest fire, and then 2 that are during a forest fire, and then another scene that's after a forest fire is out of the same path and row position. And what needs to be done right now is the post-fire, the after the fire image, this scene, I have it highlighted right now, right here. This one is not processed yet. So in ArcGIS Pro, we're going to go through a review of the geoprocessing tool called Composite Bands, and let's get right to that. So the Composite Bands tool is going to be used to create images just like this one, except a different date, right? And you can see that I've got 3 in here already. I'm just going to make some room for them. The Composite Bands tool is an analysis tool. It's a geoprocessing tool. So we're going to find it on the Analysis tab of the ribbon. You can go to the ribbon. We're going to open up the tools. Just follow what I'm doing. I'm just left-clicking on Analysis and then Tools. I'm just going to do a quick search for Composite tool. I don't even have to type the whole thing in, and it's going to find the Composite Bands tool. That's what I need to have open, and those input rasters are the first 7 channels of the last scene. That LandSat8 scene is from October 6th of 2021. The forest fire that we're talking about is the Kenogami 51 fire from 2021, very large forest fire. There were some settlements that needed to be evacuated in the area. I believe Red Lake had to be evacuated. So let's get right to it. The input rasters are going to be the first 7 bands of this last Landsat scene. So let's go and find them. Image enhancements and pan sharpening. There's the right here. Woodland Caribou Provincial Park 2021. This is where I put all the images. And you can see they're all in here. There's a whole bunch. And we've already processed a few of them. But we have not done this one down here. I only need the first 7 channels. I'm holding down the Shift key to grab multiple TIFFs to go into the input. And there they are. Now the output name and the output location need to be defined and assigned, and it's going to go into the same working directory that we've been working with for this project. So all I'm going to do is just select one of the TIFFs that belongs to this Landsat scene. I'm going to modify its name slightly. We need to know what the sensor type is. We definitely need to know the path and row. We've got to keep that. We definitely also have to keep the acquisition date, so we're going to do that, but I'm going to get rid of the rest except for the band combination, or the available bands. So we have B1, band 1 available, but I'm going to use a dash, and then I'm going to type in B7 because we have an image where we're pulling together all 7 bands. Right? That's going to be the name of it, and it matches the same naming convention that has been used in previous scenes. So save this. I haven't run the tool yet. Couple other things. If you go to the Environments tab in the Composite Bands function, we're going to also the coordinate system's fine to leave as is because the data is already projected into UTM-15 North. I believe it's WGS. We're going to go down to where it says raster storage, and we're going to work with some things here. We want to make sure that we set our pyramids to be bilinear. And if we're going to compress them at all, because we're working with 16-bit data right now, we're going to have to use LZ77. I could get into exactly why, but that's not appropriate for this video. Let's just set the parameters the same as what I have here. Okay. We're also going to be using bilinear to resample this as well. So make sure you use bilinear or cubic when you have this type of data, when it's imagery. Important. Parallel processing factor, 16. I'm going to hit sure. I'm going to run the tool, and you'll see that it may take a minute or two. I'm assuming it'll take about, I don't know, 2 minutes to run this. So while that's happening, I'm just going to flip over to the Word document and have a look and see what we have done so far, right? We've talked about the file name structure, we've talked about the path and row and the acquisition date and the file sizes that are to be expected, right? We're using the composite bands tool right now, so this should help you to understand how to answer question number 2. Question number 3, right? 2 different enhancements for the same true color band composite. And here in number 4, we started working with false color images. So we've got a 543 where we've got the full scene, and then we've got beside it a 1-to-1 raster resolution, which is about 100,000, 1 to 100,000 for Landsat imagery that has not been pan sharpened. So 752 is here. We haven't done any other band combinations because this is a lab for you as students to do, right? So do a 765, do a 654, do a 562, and you'll be off to the races. This is the next one where we really want to start looking at, the Landsat8 scene that has an active forest fire occurring, right? So we actually have 2 of them to choose from. There's the July 2nd image, and then there's also a July 18th image, both from 2021, a couple weeks apart from each other, and you'll actually be able to, in those Landsat scenes, be able to see the fire progression, and you'll be able to see ash plumes and the smoke coming off of it, and those get in the way when you're looking at the visible portion of the spectrum. The visible portion of the spectrum, smoke and ash, shows up as bright white, right? You get what's called my scattering off of it, more like a non-selective scattering, but anyhow, the longer wavelengths that are available in a Landsat8 image, like the near-infrared and the 2 shortwave infrared bands, they're great for dealing with smoke and ash plumes, right? And we're going to work with that next, okay? So that's part of what we're going to do, and then we're going to deal with the post-fire scar. That's in number 6. That means that we're going to have to look at, the area before and the area after, and you'll be able to tell, what kind of damage occurred. It says here use a color band combination of your choice, so that's cool. You can use a 562 or a 752 or something like that, or a 765, up to you. Pan sharpening comes in number 7, so I'm not going to talk too much about pan sharpening just yet, but it is next. It'll be, well, not next, but it's coming up. How are we doing over here? Looks like we're done. Perfect. The composite bands have completed. You can see we've got a green check mark, and we can see all of the parameters that had been set. We can look at the details, but there's probably not much to read there. It just says start time, and it says finish time. It says it took 2 minutes and 11 seconds to run. Nice. No big deal, right? Good, we're done with the composite bands tool. I'm looking at this and I'm saying something's not right with the projection. Let's check our map projection. That doesn't look like a perfect square to me. I'm seeing this, and if I go to the coordinate systems, oh yeah, we're in WGS84 Web Mercator. That's why. That's what matches your topographic maps and your base maps and such. We don't want that. We want to actually work with this one right here, WGS84 UTM Zone 15. That's going to match our data. You can even check the layers that are in this coordinate system, and these are all of the TIFFs, right? Looks like I have a problem with my naming convention on one of my TIFFs. Oops. I'll have to fix that. No big deal. See, as soon as you change the coordinate system, then you're better. So this is an issue. I'm going to remove it, and I'm going to go to my catalog pane, and I'm going to find it. and I'm going to change its name to better match what's going on. I forgot to put in the acquisition date. I deleted the acquisition date, and that's not good. So I'm just going to copy this out. 2021 1006 underscore. That's better. So now we're going to take that. And I had to do it in catalog because if I would have done it in the contents pane, it's only a temporary thing. So now it's completely changed. Now we're in business. Why is it black? Well, it's black because we haven't done any enhancements to it. Right, so let's have a look. It's band 1, 2, and 3. Well, we got to deal with that. We're going to go to a 432. And our stretch type, we're going to use a % clip. There it is. Now, what's with all this black data around the outside? That's called no data. And we're going to deal with that. You get that in the symbology pane. There's a mask tab down at the bottom. And you can change your no data values or your background values to no color. And they'll disappear. So here we go. Now, the scar is pretty intense, even looking at it in true color. So that's pretty cool. So this is your post-fire scar, and that came out of just running the composite bands tool. So good, we've got it, it's there. Let's drag it down to the bottom in our contents pane so we can see we've got 2020-06-13, July 13th, or sorry, June 13th of 2020. We've got July 2nd of 2021. That should be one of the ones where the fire is active. And yes, it definitely is. Look at this. That's not a cloud. That's smoke and ash. So let's. What about the next one? Oh my goodness! Look at this. The fire is still active, and we're looking at this in a different band combination. This is a 765. Look at this. The fire is definitely still active, right? So that's something interesting to think about and look at, right? So let's take some time to answer a couple of questions in the Word document so that you can see how they're being answered and you can see exactly what the point of them is. Okay? We try to clean up this image. Maybe if I work with standard deviations, that might not be so great. No, that's not terrible. 4 standard deviations. And oh, it's not looking good. Like, look at this over here. It's just dark. If we tried Esri, doing the same thing. What if we try working with the gamma? Bring the gamma up for all channels. Trying to widen out the histogram here to try to get rid of a little bit of contrast. That's not too bad. Alright, we'll deal with that. I'm going to also turn the green down a bit. And I'm going to turn the blue down a little bit as well. And I think that's good enough for now. Here we go. I can't see through anything here. I'm not liking the fact that there's a fire happening right there, but we cannot see what's happening. How are we going to deal with that, right? I'm a little too heavy on the contrast stretching. See, the smoke itself, we can kind of see through it, but then everything else goes really dark, right? So we're going to have to deal with that. Maybe I'll put this at 1. We can't see through the smoke no matter what you do in this band combination. And that's the point of question number 6, I believe, in the Word document. Sorry, question number 5. Right, so we need one screenshot in a true color because we can't see. It's opaque. Right, so let's let's take this and go full screen with it. I'm happy with that. What scale am I at? 237? We'll go to 250. 250,000. And let's get a screenshot of it. Go to the Word document. Put it right here. Now this, I'm going to crop. Now I know I said side by side, but maybe what I'll do is go top and bottom, so you can see the whole thing. And maybe I'll center it. And that's fine. Now right below it, we're going to put another one. The next one has to be set up in a wavelength range using a composite, a color composite, where the bands are all using waves that are long enough to be able to penetrate through the ash plume. That means the one that comes to mind right away is a 765. Those are all longer wavelengths than the visible portion of the spectrum. So let's go and do that. 765 is next. So let's put that back where it was. 7. You can already see through. Let's go 6. Look at that, now we can see almost everything, and if we go to a 5 here, that should get rid of the rest. There it is, see that? It's like magic. The ash plume has disappeared. Is that not the coolest thing ever? And the reason why we can't see the smoke plumes is because these longer waves are actually penetrating right through, and like you can see the flames. This is during the fire, and the fire is right here. And that's really interesting to see the progression of the flames. Of course, it's scary because, you know, we have there are people that live in this area, and this is a dangerous fire that occurred. So let's get a screenshot of this one, and in the Word document, we'll put it right below. And we'll crop it to be about the same. Where am I cropped down here? Right about there. On the sides. How did I do? Yeah, that's not bad. They're about the same. I like it. So you can see that these two wavelength, or these two band combinations, appear completely different from each other. They almost look like they're completely different images. That's the same day, the same time, same image, but different wavelengths being used to populate the color positions in this multiband image, right? This color composite is very versatile, so the spectral resolution here is great. I love it. Okay, so that answers the question. Now I could ask you to, you know, talk about it and so on, but you don't have to. I'm just realizing now that you probably can't see much with my face in the way, so let's turn me off. There you go. And you can see exactly how the question needs to be answered right there. Now, number 6, after finding and downloading a cloud-free Landsat scene that was acquired after the sensor, after the forest fire was out, by the sensor after the fire was out, please use a screenshot to show the final burn scar using a color composite band combination of your choice. Right, so that's number 6. We can do that. Just put it down on another page. Here. So all we need to do is show the scar after the fire is out. So where are we going to get that from? We're going to get it from the post-fire image. Down here. This one. Now we've got this showing the scars, and they're pretty intense, but we can do better. In fact, I think what I'm going to do is select this image table of contents, and instead of looking at it in a true color band composite, maybe what I'm going to do is look at it in a 6, 7, 5. What does that do? Weird. Maybe a 765. See, I like 765 a lot. And with the 765, you know, we can really work with a nice wide histogram, right? We don't need to have a lot of contrast stretching applied. The blue itself maybe should be brought down quite a bit to make other things show up a little stronger. See, as I apply these different contrast stretches and different gammas to each channel, we can really start to make things pop. Right, so this is the final burn scar. It's massive. Can we even get it into the screen area without it? I'm gonna have to do something here. Can we rotate? Oh, wrong way. There we go. I like that because now, you know, we can take a screenshot of the entire thing, hopefully. Try at least. It's a massive scar. Let's see what kind of, let's see how close we can get to it. I suppose that's about as close as we're going to get to it. So, and there it be. So really, this question is pretty straightforward, pretty simple. Right, so there's the scar. We'll crop this down just to take off some of the slough. That's it. That's what I'm looking for. That's all I'm looking for. Is just a way to see that you understand multi-temporal work as well. Right, so there's the screenshot of the post-fire scar. Right, pan sharpening a true color composite is accomplished using the panchromatic band, band number 8. Use side-by-side screenshots, and please find and show a community in a color composite at full 1:1 raster resolution. One screenshot should be before pan sharpening and the other after pan sharpening. The screenshots need to show the difference between non-pan sharpened imagery and pan sharpened imagery. It's worth 2 marks. So let's take a moment and just talk about pan sharpening itself, right? The panchromatic band is a better spatial resolution than all of the others. It's a 15 meter pixel as opposed to a 30 meter pixel, so you should be able to zoom in twice as much. And when I think about it, you know, when you zoom into Landsat imagery, you can zoom into about 1 to 100,000 before things start to get pixelated looking. When you have a pan sharpened image, you can zoom in to about 1 to 50,000, which is amazing. You get that much more detail. It's almost like 4 times the resolution, to be honest. It's pretty cool. So let's take care of that next in the next video. This one's short because pan sharpening is our next goal, and it's better to do that in a separate video. Alright, so that's it for now. I appreciate you sticking with it, and let's keep moving forward.